Okay, so let's try another one. So in this particular case, I mean, the starting point for each of these is probably to check for factors, right? So in this case, I'm going to write this as x minus 2, x minus 3. I think I did that right? X minus, oh, I don't know, my iPad is being a little funny today. So x minus 3. Oh, yeah, there's definitely a hole at x is equal to 3, right? So in that case, if I need to find I'm substituting 3 into the other one. Oh, it's literally the example I made up before. So look at me, so unoriginal here. But the y coordinate is 3 minus 2, which is equal to 1. So I know that there's a hole at 3, comma 1. So 3, comma 1, I'm going to put the hole in there. In this case, the zeros then is based on what's left. You have x minus 2 over 2, over 1, excuse me. So x, that's where x minus 2 is equal to 0. So when x is equal to 2, and the zeros, that is 2, comma 0. 2, comma 0, that's right there. Vertical asymptotes, but look, I reduced everything. So in this case, it has none. There's nothing left in the denominator other than a 1. There's no variable left in there. And the same for non-vertical asymptote. In this case, there is no non-vertical asymptote. It's just the function itself because it's no longer, once you reduce and take care of the whole, it's no longer a rational function. So since reduced, now on a test, you do not have to write this explanation, but I'm just writing it in so you have it and understand what's going on. Since reduced, it is no longer rational. It will not have a non-vertical asymptote. It's literally whatever is left here is x minus 2. Just keep in mind that x cannot equal 3. So that's just the equation of a line. The y-intercept, hey, is 0, negative 2, right? Remember, substitute in a 0 for x. And in this case, it's NA for the non-vertical asymptote because there is none. There's no non-vertical asymptote. So in this case, it's none. We forgot to write that with my long explanation there. So essentially, it's just the equation of a line that looks just like a line. If you put this in your graphing calculator, by the way, as the original function, it will look like this line. You have to zoom in very, very close to just that little window right here, and it'll show you that there's a gap in the line. So it's worthwhile stopping and trying that right now. But just so you know, it's just, oh, whoops, there's a gap in the line. But if you just look at it in a normal window, it looks like just the line itself.